Okay. Okay. For step number 1 in the sliding filament theory is the nerve stimulation at the neuromuscular junction, which is a motor neuron that generates an actin potential travels to the axon terminal. When the actin potential enters the AP, it opens the voltage-gated calcium channels. The calcium enters and triggers the vessel fusion. ACH is then released into the sympathetic cleft and binds myotonic ACH into the sympathetic cleft. And then the receptors on the muscle fibers, motors, and plate, they bind of the ACH opens the ligand-gated NA channels, which is the end plate potential. If this reaches the threshold, it triggers an actin potential in the muscle fiber and in the cleft that breaks down the ACH, terminating the signal so the neuromuscular junction can reset.
Calcium is released from the sarcoplasmic reticulum. Muscle AP travels along the sarcolemma and down T tubules that invaginate the cell. Depolarization in the T tubules changes the conformation of DHPR receptors, which mechanically couple to ryanodine receptors on the terminal cistern or the sarcoplasmic reticulum. The ryanodine receptors channel open the sarcoplasmic receptors into the sarcoplasm. The rise in CA2 is the key signal that begins contraction.
The role of troponin and chromosin and on the actin filament. So when calcium concentration rises, CA binds to the tropane, and the tropane changes shape, which moves the tropomyosin away from the myosin binding sites on actin, which is that exposing binding sites for myosin heads. When exposed, cross-bridge cycling can begin. Let's just continue. Okay, so the cross-bridge formation is the myosin heads are the ATP enzymes. So in the energized state, each myosin head holds ADP. The energized myosin head binds to an exposed binding site on the actin. This is the cross-bridge.
The cross-bridge cycle. Power stroke. After cross-bridge formation, myosin heads releases PI and stored energy from the conformation. The myosin head pivots, pulling actin filament forward toward the center of the sarcomere. ADP is released, shortening the sarcomere and generates force.
Detaching new ATP molecules bind to the myosin heads. Binding ATP reduces myosin's affinity for actin, causing the myosin heads to detain from actin. And then resetting myosin hydrolyzes ATP turns to ADP plus PI. The energy of hydrolysis recocks the myosin head into high energy position, ready to bind exposed actin site. If calcium is still present, the cycle repeats.
ATP's role in contraction and relaxation. ATP is essential for detachment. Without it, myosin stays tightly bound to actin. ATP hydrolysis cocks the myosin head, providing energy for power stroke. ATP powers calcium, and ATP is supplied by immediate creatine phosphate.
Okay, and then in the relaxation stage, when motor neuron firming stops, ACH doesn't release. Calcium releases from the sarcoplasmic receptors, and then they stop, and the SERCA pumps actively transports the CA back into the sarcoplasmic receptors, which is that, and the cytosolic calcium falls, and then calcium unbinds from the troponin, and the troponin returns to the blocking positions covering myosin binding sites on actin. Cross-bridge and cycling stops, and muscle fibers relax. And then for the condition, we did muscle fatigue and ATP. So during muscle fatigue, ATP levels drop which are these. And that means the myosin cannot fully detach and restart, which leads to weakening, slow, incomplete tractions, so they wouldn't move in and they would be incomplete.